David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, what does A do? So this is the A coefficient in a quadratic function. It shows up in two places in both forms of the quadratic function. So standard form, ax squared plus bx plus c, the a is just the coefficient on the x squared term. Okay? In vertex form, f of x equals a times x minus h squared plus k, remember, the vertex here is hk. This a is the same as that a. Does the same thing, is the same number. Okay? So this is a check. If you're converting from standard to vertex form, your a's should be the same when you're done. Okay, so let's take a look at what a does. In some ways, it is the most powerful coefficient in the quadratic function because it determines a lot of things, mainly the shape of the parabola. So I've got four conditions here to talk about. I'm going to explain what these things mean. The way we understand what a does is we compare it to the graph of y equals x squared. That's kind of the parent parabola. Every other parabola is a different version of this same parabola. And then take a look at that. Y equals x squared. What's a in that function? If you guessed 1, that's right. There is a 1 in front of the x squared. And here's that graph. It goes right through the origin. The vertex is 0, 0. And the first point is over 1, up 1. Second point is over 2, up 4, because of the squared function there. Okay? So what I'm going to do is go over all of these, talk about them, and then we're going to put up four functions on that graph so we can compare them to y equals x squared. Let's get started. When a is bigger than 0, which means it's positive, then the parabola opens upward. And it means that the vertex is a minimum, never gets below that value. So this one has a positive a, it's opening upward. The vertex at 0, 0 is a minimum, never going to get lower than that. When a is less than 0, or negative, the parabola opens downward and the vertex is a maximum. Pretty straightforward. This is where it gets a little bit more complicated. When a is bigger than 1, or smaller than negative 1, that means that the parabola is going to be narrower than y equals x squared. So if we graph that parabola, it would be inside. It would be more of a narrow parabola. Okay? Now, if a is between negative 1 and positive 1, that means it's kind of a fraction. Okay? It's going to be between negative 1 and positive 1. It might be a half, it might be a quarter, it might be 3/8, something like that. That means the parabola is going to be wider than y equals x squared. So when that one gets graphed, it's going to be wider like that. Okay? And those two last points are easily explained. Let's just say a is 2, okay? If I plug in my value for x and I square it, before I get my y, I'm going to multiply that result by 2. So the y value is going to increase faster and it's going to make a narrower parabola, okay? Let's say my a is positive 1/2. So it's not quite 1, it's less than 1. So that means when I put my value in for x and square it, before I get my y value out, I'm going to multiply it by 1/2. So the y is going to grow slower than it would normally grow in terms of y equals x squared. Okay, let's look at four graphs that are going to tease out the relationship between a and how the graph actually looks. My four functions, 2x squared, 1/2 x squared, minus 2x squared, and minus 1/2 x squared. So these first two are positive. We know the parabola is going to open up. These two are negative. The parabola is going to open down. This has an a that's bigger than 1. So this parabola is going to be narrower than y equals x squared. This parabola has an a that's between negative 1 and positive 1. So this parabola is going to be wider. And then the same would go for these two, narrower and wider. Okay, so let's do this. Let's make a quick graph of 2x squared. So when I put 1 in for x, It's going to square and get 1. But before we get our y value, we're going to multiply it by 2. So that first point is going to be 1, 2. It's going to be up there. And then 2 is going to get squared to be 4 multiplied by 2. It's 8. So it's somewhere up there. Okay? Now I can get this other point by reflecting across the x-axis or the y-axis. And so here's my other point. I know the vertex is the same, so this new parabola is going to look like this. So this is y equals 2x squared. Okay? So this parabola is narrower than y equals x squared, just like we expected, or well, like I showed you. Now let's do the 1/2 x squared. Vertex is the same. So if I put 1 in for x, I'm going to square it, and I get 1, but then I multiply it by 1/2. So instead of 1, 1, like this parabola does, now I'm going to have 1, 1/2. Oops, let's do it over here in the positive. If I put in 2 for x, I'm going to square it, get 4, but then multiply it by 1/2, so now I'm back to 2. So this probably goes to the point 2, 2, which is right about there. And then, remember, axis of symmetry in this case is the y-axis. It goes right through the vertex. So my other 2 points can just be gotten by reflecting across. And now I can graph this parabola, or draw its line. And this one is y equals 1/2 x squared. Okay? So in the middle, that's y equals x squared. This next one is y equals 2x squared. My a is bigger than 1, so it's narrower. And then this third one is y equals 1/2 x squared. My a is between 0 and 1, so it's wider, and sure enough, it's wider. Okay? Now let's take a look at these two negative ones. I'm going to go a little faster because the process is the same that we just did for these. It's just going to open downward. Okay? So 2x squared. I'm put in 1 for my x squared, and then it gets squared to 1, and then it gets squared to 1. It's going to get multiplied by 2. So I'm going to have 1, negative 2, and negative 1, negative 2. So this parabola is going to look like that. So this is y equals negative 2x squared. And then this one here, it's going to be a wider one. Let's put in, if I put in 1 for x, I'm going to square it, still 1, multiply it by 1/2, I get negative 1/2. So I go over 1, I'm 1/2, reflect that across, and this parabola looks like that. This is y equals negative 1/2 x squared. Now if I graphed, I didn't put in this one, y equals negative x squared. This one's closely related to our y equals x squared. It looks just the same, except it's going to be opening downward. And that one would come right in between these two. Okay? So that's how you use A to graph a parabola. Now we're going to put this all together in a sketching parabolas video where we're going to talk about all these things. Plus, remember, vertex form also tells you where the vertex is. And then you're also going to need to find your intercept. So we'll do that in the next video. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.